Dear moderator, Dr. Wei, ladies and gentlemen, I am Ming-Jer Tsai, Director of the Experimental Forest, National Taiwan University. The topic today I would like to present is Prospects of Forest Carbon Sink, a case study of Experimental Forest, National Taiwan University. Dr. Zhang is a co-author. He is a research fellow, the Experimental Forest, National Taiwan University. At the first, I would like to talk about importance of forest and the SDGs. According to investigation, we know the forest products provide more than 20% of forest farmers' income. And the terrestrial biodiversity provides shelter. Also, the forests provide stabilization of the global climates. So, familiar forest goods and services support SDGs. But hidden waste deforestation undermines SDGs. The sustainable forest management could protect, restore, and promote sustainable use of terrestrial ecosystems. The sustainably managed forest could combat desertification and halt and reverse land degradation and halt biodiversity loss. As you know, healthy forests could store carbon. However, decaying forests release carbon. The growing forests absorb carbon and release oxygen. If you do not cut down the trees will get older, and the older forests release their stored carbon slowly as they decay or rapidly through wildfire. So we must cut down the trees in the proper time to build wood structures, to produce furniture, and the carbon will store in HWP, harvested wood product, will store in wood structures and also wood furniture. Forest area of Taiwan is 2,197,000 hectares. It is about 61% of the land area of Taiwan. Plantation area is 20% of the total forest land in Taiwan, including 51% of conifer plantation. Three strategies and 10 actions were proposed for forest carbon sink in 2022. First, increasing forest coverage. Second, enhancing forest management. And third, utilization of domestic timbers. For increasing forest coverage, the goal by 2030 is afforestation areas reaching 12,600 hectares. it will increase about 107,000 metric tons of carbon dioxide per year. Second, for enhancing forest management, the goals by 2030 are: first, forest management areas reach 16,400 hectares. Second, bamboo management areas reach 30,000 hectares. Together, it will increase about 454,000 metric tons of carbon dioxide per year. For utilization of domestic timber to substitute the timber imports, the goal by 2030 is timber production 200,000 cubic meter. It will increase about 197,000 metric tons of carbon dioxide, carbon stock. We expect the forest carbon sequestration is 758,000 metric tons of carbon dioxide by 2030. Following, I will introduce the experimental forest, National Taiwan University. In 1902, the experimental forest, National Taiwan University, was established during the period of Japanese colonial period as the Taiwan Practice Forest. In 1949, the forest was entrusted to the National Taiwan University. In 1950, named as the Experimental Forest, College of Agriculture, National Taiwan University. In 2002, renamed as the Experimental Forest, College of Bioresources and Agriculture, National Taiwan University. We have 4 objectives. They are education, research, forest management demonstration, and environmental conservation. The location: the experimental forest is located in central Taiwan, and the elevation of the experimental forest ranged from 220 meters to 3,952 meters. The area of the experimental forest is about 32,770 hectares, about 1% of Taiwan area. Other than utilization, we have natural forest, 11,000 hectares, plantation, 12,000 hectares, and the cooperative plantation, 5,000 hectares. The progress in forest carbon sinks in experimental forest. In Taiwan, we have only reforestation and afforestation methodology. In experimental forest, reforestation and afforestation will be completed by 2021 with a newly planted area of 1,384 hectares. Based on the calculation of 9.76 tons of carbon dioxide sequestered per hectare per year, it is estimated that 1,316 tons of carbon dioxide can be absorbed annually. Over 30 years, we calculate a total of 39,469 tons of carbon dioxide can be absorbed. In this year, improved forest management methodology and improved bamboo management methodology will be developed. However, harvested wood product methodology and forest soil carbon sink methodology are still pending. As mentioned, the experimental forest has plantation 12,000 hectares and the cooperative forest 5,000 hectares, together 17,393 hectares. After calculation, the forest can remove 168,000 tons carbon dioxide per year. And via sinking, the carbon sink in our forest can possibly increase 30%. That means the forest can remove 219,000 tons carbon dioxide per year. Soil carbon sink, still no methodology in Taiwan. And what we do in experimental forest, we establish baseline of soil carbon sink for national scale. Establish parameters of forest soil carbon sink and adapt it in methodology. We have also established century model and estimate Taiwan's forest soil carbon stock. Talking about what circular economy in the experimental forest. The experimental forest combines smart production management to reduce carbon emissions in various wood processing processes. It will develop a circular economy that can be used as carbon substitutes, such as solar photovoltaic systems, wood pellet processing equipment, waste wood providing boiler fuel, and heat sources required for drying kilns. The goal is to build a carbon neutral woodworking factory and provide an exemplary reference for the industry. The visions of Taiwan's forest carbon sink in the future are following. First, increase forest carbon sink. Second, enhance soil carbon sink. Third, carbon preservation in harvested wood product. Fourth, wood product circular economy. And biomass pellet for power generation. Thank you for your attention.